We just discussed two TD control methods, Sarsa and Q-learning. In this lesson, we'll talk about another TD control method called Expected Sarsa. By the end of this video, you will be able to explain the Expected Sarsa algorithm. Recall the Bellman equation for action values. Here you can see the expectation over values of possible next state action pairs. Breaking this expectation apart, we see a sum over possible next states as well as possible next actions. Sarsa estimates this expectation by sampling the next state from the environment and the next action from its policy. But the agent already knows its policy, so why should it have to sample its next action? Instead, it should just compute the expectation directly. In this case, we can take a weighted sum of the values of all possible next actions. The weights are the probability of taking each action under the agent's policy. Explicitly computing the expectation over next actions is the main idea behind the Expected Sarsa algorithm. Now let's look at the Expected Sarsa's learning update. Since Expected Sarsa is still based on the Bellman equation for action values, it uses the familiar form of learning update. The algorithm is nearly identical to Sarsa, except the TD error uses the expected estimate of the next action value instead of a sample of the next action value. That means that on every time step, the agent has to average the next state's action values according to how likely they are under the policy. For example, with the following values in policy, Expected Sarsa would use a value of 1.4 for its estimate of the expected next action value. However, there is a huge upside to calculating the expectation explicitly. Expected Sarsa has a more stable update target than Sarsa. Let's look at an example to make this more clear. In this example, the immediate reward is deterministically 1. Both Sarsa and Expected Sarsa start out with the true action values for the next state. Even in this idealized case, the next action sampling that Sarsa does can cause it to update its values in the wrong direction. It relies on the fact that in expectation, across multiple updates, the direction is correct. By contrast, Expected Sarsa's update targets are exactly correct and do not change the estimated values away from the true values. In general, Expected Sarsa's update targets are much lower variance than Sarsa's. The lower variance comes with a downside, though. Computing the average over next actions becomes more expensive as the number of actions increases. When there are many actions, computing the average might take a long time, especially since the average has to be computed every time step. In this video, we showed that the Expected Sarsa algorithm explicitly computes the expectation under its policy, which is more expensive than sampling but has lower variance.